So when we work here with the second part of lesson 2 in unit 7, we're going to work with the same type of multiplication but larger polynomials. So in our previous lesson, we really understood, hopefully, the distribution, box, and vertical methods for multiplying, but our focus was binomial multiplied with binomial, or what we call a 2 by 2. Okay, well, just as we do it with those, when we do multiplication of polynomials that have maybe 2 or more terms, we still can use the exact same methods. We can use the distributive property and think of it in terms of distributing each term in the first parentheses and making sure it has the opportunity to be multiplied by the other polynomial. And you could also use the box method or the vertical method. And I honestly, when we did the 2 by 2s in our last lesson, I really leaned toward the distributive, or in that case we called it FOIL. I like to lean on that, and I'm just like, oh, I'm just going to FOIL it. But honestly, when we get into larger ones, whether it's 2 by 3s or even maybe 3 by 3 polynomials where there's going to be a lot more terms, first of all, the acronym FOIL doesn't really work anymore. The work is still the same, but we're going to have more than just the 4 products. It's going to be more than just first, outer, inner, last. As you can see here, you've got to make sure you do the x times all 3 of the terms in the second polynomial. And the 5 then needs to come in and be distributed out. So when we do that, you can see you get a lot more than just 4 products, you know, the FOIL, the 4-letter acronym. And so the word doesn't work, but really the work is still the same as that distribution. Okay, but because it does get longer and there's a lot more terms and products to work with, I really think that this is where the box method or maybe even the vertical method really shine in terms of keeping those organized and keeping track of all of the products and making sure that you have everything, all your bases covered, that everything that needed to be multiplied got multiplied. So that's where those benefits come in. Basically, for the box method or the vertical method, they really help organize these larger products. Okay. So other than that, though, honestly, what we're going to do today is going to feel very familiar. We're still multiplying polynomials. We're just working with slightly larger ones. We'll do a few 2 by 3s and perhaps even a 3 by 3. And again, you have the same options really as last time, except for the acronym FOIL. Option number 1 is just to think of this in terms of distribution. So I could, let's do number 1 here. I could take this binomial, k plus 2, is being multiplied by this trinomial. And if I think of this in terms of distributing, the idea is to take k, and for a moment we'll ignore everything else. I would say, okay, well, I'm going to start with the term k, and I'm going to distribute it to the other polynomial that I'm multiplying by. And I want to make sure that that k has the opportunity to be multiplied by all of the terms in my second polynomial. So I would do k times the 3k squared plus k plus 1. And then as I distribute that, I would do 3 times this, k times the 3k squared. Now when we're multiplying like bases, we add those powers. We learned that last semester, and we're reviewing that now. So that is not a very pretty 3, but you know what I mean. So if I already had k squared and I'm multiplying by an additional k, it is now going to be 3k to the third. So sometimes it helps to do this separately. Do your coefficients. 1 times 3 is 3, and then do your powers. K times k squared, I'll add those exponents, and I'm going to get k to the third. Here, k times k is also k to the second power. So again, 1 times 1 is still 1, and k times k is k squared. And then k times 1 is just k. Okay. My writing is a little weird today. Okay, but once we're done with that, we can't stop there, and we have to just remember that there's another entire term, in this case, that also needs the opportunity to be multiplied by every term in that second polynomial. So I also have to take that positive 2 and multiply it by that entire second polynomial, the 3k squared plus k plus 1. So I'll distribute that. So 2 times 3 here is 6k to the second. Okay, and then 2 times k is just 2k. and 2 times 1 is just 2. So because this was a 2 by 3, a binomial times a trinomial, 2 by 3 is 6. I expect to have 6 products when I'm done. So 1, 2, 3, 4, 5, 6 products when we're done. So that looks good. And as usual, there'll be a few that are like terms that can be combined. So I have a k to the third. So I'm going to search and see if I have any other ones. And if I don't, then that is okay. Then that's just the way it's going to stay in my answer. And then I have a k to the second. Do I have any like terms? I do right here. Here's another k to the second. So I have 1k squared, or k to the second, plus another 6k squared, or k to the second. So I'll combine those. 1 plus 6 is 7k to the second. Notice when we were multiplying, we added the exponents, but when we're combining, I mentioned this in the last lesson, you're not going to change the type of term it is. They're both k squareds, I just have more of them. So if they're like terms in this second step, when you're simplifying and just combining your like terms, you're going to add your coefficients together and your type of term stays the same. So it's going to be 7k squareds. Okay? And then I have a couple of regular k's. I have 1k plus 2k's. So if I combine those, that's going to be 3k's. And then I have my 2, and I don't have any other constants, so that 2 is going to stay. Okay? So that would be the final product in standard form, simplified, packaged, ready to go. Okay. Now, another thing that I'm going to mention when we do these, especially again, this is all about managing lots of terms, right? So the work itself, each individual step isn't too bad, but we have more of it. So I'm going to give you another suggestion. Let's try number 2 together. Let's say that I'm doing this by distributive property. Here's what I'm going to recommend, and I think you don't have to do it. It's just a suggestion, but I think it helps a lot of people. Let's say I start like a normal. I'm going to take my first term distributed. So I'm going to do 2m times the second polynomial. And so that's times that m squared plus 4m minus 5. And then I'll distribute that. So 2 times 1 is still 2, and m times m to the second is m to the third. Okay, and then 2m times 4m, well, 2 times 4 is 8, and m times m is m to the second. And then 2m times a negative 5 is 2 times negative 5 is negative 10, and I still have my m. Okay, so there's my first product. Looking good so far. Okay. And then I go back and I do my 3, and I'm going to distribute it. So I'm going to take that positive 3 and make sure it has had the chance to be multiplied by that second polynomial. But look what I'm going to do. This is going to be where I'm going to recommend. So instead of getting this long string that's all on the same line, and then I'm going around trying to chase common like terms and trying to make sure I find all the things that are alike and combine them, here's what I'm going to suggest you do. This is a little bit like the vertical term, but when I do my first product, 3m squared, that's going to be 3m squared. Instead of writing it here and continuing this long line, I know this is going to be 3m squared. I'm going to go ahead and write it underneath, vertically underneath, so that it's already lined up and ready to go for me. So that it reminds me, oh yeah, these guys are like terms. In a minute, we're about to combine them. To me, this makes a lot, it helps a lot keeping track of multiple, long terms when we're combining. When I do my next product, 3 times 4m, well, 3 times 4m is 12m. That's an m term, so I'm going to line it up right underneath my other m term. So I'm going to have positive 12m's. Instead of continuing to write them on the same line, I'm just putting it underneath, because I know in a moment I'm going to want to combine them anyway. This just makes it easier for me to organize. Okay? And then I have 3 times negative 5, which is negative 15, and I look to see there's nothing to combine that with. No problem. I'll just write it by itself, nothing lined up. I know that that's just going to go straight down into my answer. Okay? So I think that makes a really nice difference in terms of combining. Makes it easier to see what I'm combining and so forth. So now I can just drop my line and combine straight down. This didn't have any like terms. So it just comes down straight into my answer. And then here for my m squareds, I have 8 plus another 3. I really have a total of 11 of these m squareds. Negative 10 and a positive 12 is a total of 2 m's. And again, the negative 15 didn't have any like terms, so it just gets, it just is brought down, straight the same way. And there it is. There's our product and our final product, and it's nice and simplified, and it's in standard form. Okay, so let's try number 3. I want y'all to try this one on your own, and then you can check your answer. So hopefully you gave that a shot, and you can see if your answer was correct. If you multiplied this correctly, you got x to the third plus 7x squared plus 13x plus 15. And if you didn't get this, kind of backtrack and see if you can find where the mistake might be, and how to fix that. Okay. All right. Number 4 looks intimidating because it's got a few fractions in it. You know what? Fractions are not nearly as bad as y'all think. They're a lot easier to work with many times than decimals, I promise. But if you want to go ahead, and this was an optional one, but I'm going to go ahead and quick pause, let you practice it if you really want a challenge here, and check your answer. All right, and you can check that if if you're up for the challenge for something a little bit more interesting here. You should have gotten 32p to the third minus 14p to the second plus 5p plus 3/8. Okay, and again, the steps are really exactly the same. All right, so you could see the steps are the same as what we did in the previous lesson. It's just a few extra products, but because those are, those result in a larger sort of string of values. This is, like I said before, where the box method really shines as far as keeping stuff organized, especially if it's a 3x3. Once I get to that point, I really usually rely, my box method is going to be my go-to. Okay, so just like I mentioned, if you're doing a two-term or a binomial multiplied by a trinomial, a 2x3, then you need a 2x3 box. It doesn't really matter whether you do 2 columns and 3 rows or 3 rows and 2 columns. Just make sure it's a 2x3 box, and then line up your polynomials appropriately. So n plus 3, that's my binomial, so I need to put that one here on the side, and then my trinomial, n squared, a positive 5n, and a negative 1. And then, like I said, this really is just a nice way to keep things organized. And then you do the same work. So you're going to just make sure that in each of these, you write the corresponding product for each of those, rows and columns. So n times n squared is n to the third. 3 times n squared is 3n squared. Let's see, 3 times 5n is 15n. N times 5n is 5n to the second power, or squared. N times negative 1 is just a negative 1n, or negative n. And 3 times negative 1 is negative 3. And so it's just a nice way to just make sure you've covered all your bases and that everything that needed to be multiplied is. But then you also still have to keep an eye on like terms. So you have these 6 products, and you want to recognize that you've got a couple of like terms right here that can be combined, and a couple of like terms right here that can be combined. So before we write our final answer, we want to make sure we've combined any like terms. So the n to the third stays. It didn't have anybody to. Then 8n squared. I'm sorry. I gave it away. 3n squared plus 5n squared. Well, that's 8n squared. And then here 15n and a negative 1n. That's 14n's. And then the negative 3 doesn't have anybody to combine with. There's no other constants. So there you go. All right. So that's using the box method. Okay. And I'm just telling you my preferences after doing this for many years. If I'm doing a 2x2, I typically just go right for FOIL. But when I have bigger ones like this, typically the box method wins as far as, the method that I like the best. But you look at it and you decide which one you like. So try number 6. Let's give that one a shot, and then you can check your answer. Okay, so hopefully you gave that one a shot on your own. Let's go ahead and work it together. You have your two terms need to be, your binomial needs to be wherever you have the two rows or columns, and then trinomial across the top because we have three of those. And then again, it's just finding those products. And the big thing here is to remember that when you're multiplying, you do add these exponents. They don't have to match, by the way, they don't have to be like terms, and you add them. But in the second stage, when you're combining them, they do have to match, and you only change the coefficient. So I just want to remind you of that. Let's take a look at number 6 here. 1 times 3 is still 3. Those are my coefficients. And then x squared times x squared, I add those exponents, and I get x to the 4th. Okay. X squared times a negative 2x, well, negative 2 times 1 is still a negative 2, so the coefficient's going to be negative 2. And then x squared, or the second power, times an extra x, is now going to make that x to the 3rd. Because again, there's an implied 1 here if we don't see it, and I'm adding those powers to get my new product. Okay, negative 6 times x squared, well, negative 6 times 1 is still negative 6, and then I still have the x squared. So that's that product. Okay, and then we can also do the 8x. So 8 times 3 is 24, and then x times x squared, again, we add those exponents in multiplication, so that's x to the 3rd. Here we've got 8 times negative 2, which is negative 16, and then x times x is x to the 2nd power. And then 8x times a negative 6, well, 6 times 8 is 48, so this will be a negative 48, and I still have that 1x. So there it is. And I'll look for any like terms before I finalize my answer. So I've got, but see, in this phase, a minute ago, I could multiply, terms even if they weren't exact, like terms or exact powers, because I'm adding them. But now in combining, I can only combine the ones that are a perfect match as far as the variable and exponent. And I can only combine those. And when I combine them, the only thing that's going to change is the coefficient. The coefficient is what keeps track of how many of that term you have. So this guy does not have any like terms. But here, if I have 24 of these x to the 3rds and then a negative 2x to the 3rds, well, 24 negative 2 is really 22. I really have 22 of those x to the 3rds. See, my power stays the same in that second part of the problem. Okay. Wow, that was not very pretty. Okay, and then my x to the 2nd, same thing. I combine my coefficients and the type of term stays the same. So this is a negative 22x to the 2nd. And then last but not least, this guy has no other x terms to combine with, so it stays. Okay. All right, so if you want an added challenge, try number 8, and then these can be extra practice here, and we can definitely go over those later if you want. So last but not least, I'm just going to finish off with just a quick reminder that you also have the option of the vertical method. I still think this is the bomb. Not all my kids agree, but I just think it's really cool to remind you, hey, if you could do it when you were a 3rd grader, you can do it now. And it's really the same concept or the same idea. So let's try one here just for practice. And again, you could use any of these other ones as extra practice, either with the vertical method or any other method. But let's go ahead and try one using the vertical method. So if we were using vertical multiplication, we would just set up one over the other and really go through the process just like you do, with numbers. And so we're going to, typically we like to put the larger number on top, so we're going to do the same thing with our polynomial. I'm actually going to put that 4a to the 2nd minus 2a plus 6 on top, and then the a plus 5 that I want to multiply that by right underneath. So there's my multiplying. Okay, and just like you did, I would start with a 5, and I would give 5 the opportunity to be multiplied with every single one of these, just like you did with regular numbers in elementary school. So 5 times 6 is 30, and it's a positive 30. 5 times negative 2a is a negative 10a. And 5 times 4a squared is a positive 20a squared. Okay, so when I multiplied all that by 5, I get 20a squared, negative 10a, and a positive 30. And then we start all over again with the a, and if you want, you can put that little 0 placeholder like you used to, or you can just leave it blank. Just basically, the idea is line up your like terms. So when you do a times 6 and we get 6a, I just want to make sure that I line that 6a up right underneath the other a term, sort of like we did in these examples at the beginning of the lesson. Okay, and so that's a positive 6a. And then a times negative 2a, well, negative 2 times 1 is negative 2, and then a times a is a to the second. And on this last one, a times 4a squared is going to still be a 4, because 1 times 4 is 4, but a times a to the second is now a to the third. Okay, and then we can drop our line down and combine straight down. So the 30 doesn't have anybody to combine with, it just comes straight down. Negative 10 and a positive 6 is a negative 4a. Positive 20 and a negative 2 is 18 a squared, or the second, and that's positive. And then this guy didn't have anybody to combine with, so it comes straight down. And that's our product. Okay, so vertical method, they're all just different ways of organizing the same concept, that every term in one of your parentheses or polynomials has to have the opportunity to be multiplied by everything in the other one. So you give 5 the opportunity to do everything, and then once it's done, you go back and you do it with the a, and then combine like terms if necessary.